Please welcome Juan Lavista Ferres, Chief Data Scientist and Lab Director, AI for Good, Microsoft.
Thanks, everybody. As humans, we naturally gravitate towards focusing on negative news. This is something that likely comes from evolution, which means that our ancestors, they were more focused on good news. Those likely didn't make it. But as a result of this, we typically often to see a more pessimistic outlook of the world. And it's difficult sometimes to see how much progress we have made as a human race. If we look at metrics like infant mortality or people living in extreme poverty or even global literacy rate, decade after decade after decade, we have seen tremendous improvements and tremendous progress. And these improvements are mainly driven by technology. From electricity to vaccines to communication, technology has played a fundamental role in advances in society. And within this technology, there's a subset of technology that has a significant effect. This is something that Brad mentioned today. These are GPTs. That is not the ChatGPT. It's GPT as general purpose technology. And this general purpose technology can affect the whole, have an impact in the whole way we live and the way we work. From electricity to the printing press, to trains, to planes, all of this technology has had changes in the way we work. AI is the next GPT. AI has the power to improve the way we live and the way we work and to change it also. And this is something that we have experienced in the last 5 years as part of our AI for Good lab. We have seen firsthand how AI can change and can affect our lives. This is a picture of Niger in Zinder in Niger. This is the last time they have done census. This is how people understand what Zinder is. But this is the latest picture of the same city, just last year. Every single blue dot here is a house that is not in any map. And the challenge is that if we don't understand where people live, we cannot help them on areas like disaster preparedness or even disaster response. In those 10 years, this city has doubled the population size. So we have, if you live in the global north, if you live in the US or Europe, we have this illusion that we know where people live, because you can always go online and see that your house is there in your maps. This is not the case in a significant portion of the world, particularly affecting the sub-Saharan Africa. So for the past 2 years now, we have been working with IHME, with ITU, and with Planet of using high-resolution satellite data to map every single structure in the whole planet. Using this technology, we can now have a very good understanding of where people live, and if there is migration, where is that migration going? This is critical for the organizations that we work and we partner to help them understand how to solve their problems. This is, with ITU, for example, we've been working now of understanding where people do not have connectivity. If we know where people live that do not have connectivity, we can help countries prioritize. Because if people don't have connectivity, in an early warning for all scenario, no matter how much technology we have, we will not be able to tell them that there is a problem. We also have been working in biodiversity conservation. This is something that we've been doing in the Amazon now, where for the past 2 years, we've been working with governments like Colombia to help them understand and track deforestation, but also help them track biodiversity. Our latest project, Project Sparrows, is about having an understanding and communicate biodiversity information both from camera traps and acoustic data, and help researchers understand the health of the forest. This acoustic data, the one that you can hear, is very difficult for a human to detect. You need a certain level of expertise. But these AI models can use this information and detect these type of animals. For the past 2 years, we have also seen a step function in AI, driven by large language models. Large language models have a lot of power, but they also have limitations. So in order for us to use this technology, we need to understand the power, but also the limitations that it has. The first thing that is important for us to understand is these LLMs are just math. So no matter how sophisticated these large language models can appear, behind the scenes, this is just math. To the point that if Excel allow, it doesn't, but if Excel allow very huge, big formulas, you could run a large language model directly from Excel. LLMs do not have reasoning or intentionality. These outputs are driven from statistical correlations. They are not thinking. They are just learning the relationship between words and using this relationship to actually have these outputs. The only thing a large language model is doing is trying to predict what is the next word. So, for example, if you say, this morning I woke up and saw a beautiful blue, if I ask the room right now, people will say blue sky, blue bird, blue car. That's the only thing these large language models are doing, is learning the probability distribution of what is that next word. This is the only thing a large language model can do. LLMs do not know what is true. They don't have the concept of what is true. They learn what is true from the training data set. So if your training data set has issues, these LLMs will repeat those issues. This is why it's critical for us to understand and invest in good data sources. LLMs can hallucinate, because the only thing we're doing is trying to predict what is the next word. They really don't know what the output is being correct or not. This is what we call hallucinations. So it's critical for us to use them and understand that some of the outputs will not necessarily be trustworthy. That's why we need to make sure that we trust but verify. But still, LLMs can be extremely powerful. The open web is the most important data repository we have in the world. Majority of our human knowledge is stored in the web. And until 2 years ago, we couldn't leverage that knowledge. Yes, you could have a person that would use a search engine, get results, and then use have a human in the middle. Thanks to large language models, now we have the capacity to use that human knowledge and gain knowledge from that, convert that information, that data into actual information. That is the step function. And if you look at the press and you look at some of the research, whether it's biology or math or legal, LLMs have consistently shown that we can pass a lot of these exams. Why? Because it has that knowledge, and it can act on that knowledge. This is also extremely powerful. Multi-models can also solve other problems. In computer vision, this is called muffins versus chihuahuas. And this is a toy computer vision, what we call a toy computer vision problem that requires a lot of data and is not that easy to solve. GPT-4o can solve this problem without a training data set. This is a lot of projects that we have fail because we don't have data. Some of these vision models can solve problems without being trained. This is what is called zero-shot learning. We don't no longer need a training data set. These models can help us find parking. That, by the way, is not that easy. But they still have limitations, and we need to understand the limitations. For example, one limitation what we found is GPT-4o cannot find Waldo or Wally. LLMs can improve productivity. one of the first use cases of LLMs, people sometimes forget that before GPT-4, we actually had a Copilot running in GitHub. As software developers, has significantly improved our capacity to code, with people using GitHub Copilot being solve the same problems 55% in 55% less time. This has significant impact in the productivity of software developers. BCG did a study last year where they show that a group of their employees using Copilot or GPT-4 were not only solving more tasks, but faster and with higher quality. This is an extreme improvement in productivity for organizations like BCG. Generative models can also have a dramatic help on the digital divide. We live in a world where 1.3 billion people lives with a severe disability. 40% of global population do not have access to education in a language they speak or understand. And almost everybody in the world, 99.95% of the world, do not know how to code. Having access to AI is breaching each one of these gaps. In the case of disability, I will show multiple examples where people with disabilities are leveraging this technology to help them live and work. In the case of languages, you can use these language models to translate. Majority of the content is not accessible. If you were lucky enough to live in a country where English is your first language, well, suddenly 50% of the web is accessible to you. The multiple languages, that knowledge is not there. But thanks to large language models, we are able to translate now without a big investment that would take to do that translation. In the case of coding, even after 20, 30 years that we have been trying to help people get coding skills, this is not happening. Like the percentage of people that know how to code in the world hasn't dramatically changed, it's not gonna change. Thanks to large language models, for the first time, we have the ability to code in your own language. Whether it's English, Spanish, or Mandarin, you have the ability to code in your own language. A lot of the things that you can do today in ChatGPT, or GPT in general, is something that computer scientists could do before by coding. But that was a very niche part of the global population that knew how to code. Now, thanks to large language models, you have the ability to use your language to code. This is a game changer. And this is going to change the way everybody works. It's not that we're not going to need software developers or coders, but it's going to see that you will have many more of those and many more tools for those. This is going to change everybody's lives. When we think about this is going to significantly reduce that digital divide. But it can also exacerbate for those that do not even have access to it. Like Brad mentioned today, if you don't have access to electricity, if you don't have access to the internet, if you don't have access to a computer, you will not be able to use AI. If AI is not accessible in your language, you will not be able to use AI. So those that have access to this technology, the technology can significantly breach that digital divide gap. Those that do not have access, that will get exacerbated. And this is why it's so critical for us to make sure that we invest in all of those layers, from electricity, communication, internet, access to smartphones or devices. This is critical. Once a week, I teach computer science at the school, at the elementary school. And I have 12 students. And even with 12 students, it's relatively difficult for me to make sure that every kid can learn. When you look outside the global north, some of those ratios can be to 1 to 50 between teacher and students, 1 to 50 to 1 to 100. I don't know how people could teach 100 students in one class. But like Sal Khan mentioned, leveraging technology like GPT, you can use you can use AI as a tutor, not replacing that teacher, but actually helping that teacher make sure that every student learns. This is also something that is a game changer. If, in the case of the visually impaired, like the example I mentioned about the Chihuahuas versus muffins, the reason why those zero-shot learning scenarios are critical is because organizations like Be My Eyes, if a person is blind, can now use a smartphone to navigate through the world. Be My Eyes, that's the organization that is doing that. Is using smartphones to navigate through the world. Before that, they would leverage an army of volunteers that would get pictures and would describe to the person what is this person looking at. That, of course, will take a delay, would need a lot of volunteers. Now, these vision models are doing this. And this is changing the way people that are blind can navigate through the world. Jessica Lawrence is a person that works in Seattle. And one day I was reading her LinkedIn and says, and someone born blind, when I think back, I remember this as the year when AI vision got real. Because for at least 20 years, a lot of people in computer science, including a lot of people in Microsoft, has been trying to solve that same scenario. If I have a smartphone, can I get a description of what is in that picture? And that was an extremely difficult problem that we couldn't solve. There were great demos, by the way, but we really couldn't solve. Now, thanks to vision models, this is working. And she said something else in her post. It's like, one of my favorite aspects of the world of AI vision is how it evokes emotion in me. I've literally gone through and relabeled all my favorite pictures of my kid on my phone because of the level of nuance it communicates to me about her face in each one. This is the person that for the first time can observe the picture of her daughter and the emotions of her daughter. This technology, when we're thinking about how AI is changing the world, is really changing the world for people that have disabilities. AI is a new general purpose technology that provides amazing power to change the world. Together we can build a future where AI can benefit everyone. Thank you very much. And I'm a bit early today.